In this lecture, I'll talk about the audio in class. The audio in class provides a mechanism to record audio at a low level. First, the audio in class saves the PCM audio data as is, unlike the audio recorder, which saves audio in a known file format. In the case of audio in, developers have to manually create and then specify a buffer. Multi-buffer is supported, and auto-switching between buffers is supported. The audio in class specifications are as follows. First, microphone input devices are supported, and mono and stereo channel options are supported. Both 8-bit and 16-bit sampling depths are supported. Now, I'll talk about the functions provided by audio in. In the process of preparing audio in, you have to specify the recording source device, the recording audio as either mono or stereo, the sampling type, the sampling rate, and the sampling depth. In the last preparation step, the function to add a buffer for the recording is provided. There are also various get functions. These functions get the minimum and maximum buffer size for recording, and get the type, sample rate, and sample type of the channel optimized to the features of the device. Additionally, to actually perform a recording, the start, stop, and reset functions are provided. The listener used in audio in is iAudio in listener. This listener has the on audio in buffer is filled function, which is called when the audio in buffer becomes full. If a higher priority task takes control of the device, the on audio in interrupted function is called. If the device is released, the on audio in released function is called. Audio in state transitions are as follows. When audio in is constructed, it changes to the initialized state. To use audio in, the prepare process has to be performed in advance. In this prepare process, various properties are set in audio in. If the start function for the prepared audio in is called, the audio input from the microphone starts being recorded to the buffer. If the buffer becomes full while recording, the on audio in buffer is filled function is called. This function should empty the buffer quickly so that the recording can be continued. To temporarily stop the recording during a recording, call the stop function. To resume a stopped recording, call the start function again. If the unprepare function is called, the recording is permanently stopped. I'll now show you step by step the general procedures to record audio in the buffer using audio in. First, I'm going to talk about the audio state transitions. The audio in class is created, constructed, and then prepared. The recording buffer is added to the created audio in, and the recording starts. If the operation is interrupted, the on audio in interrupted function is called, and the audio in is automatically stopped. If the interruption is released and the audio in becomes available, the on audio in released function is called. At this time, in general, audio in is restarted. If the on audio in buffer is filled function is called, you have to move the contents from the buffer to another storage device and rewind the buffer so that the recording can continue. If necessary, you can stop a recording using the audio in stop function, and then you use the data stored in the buffer. Then, to release the audio in, call the unprepare function of audio in and delete the object. Now, I'll show you some actual sample code. First, the listener object is created with a file pointer and an audio in pointer. These two values are received from the construct function of the listener object and set. If the on audio in buffer is filled function is called, data in the buffer is quickly copied to a file, and the buffer is cleared and added to audio in again. As mentioned previously, the onAudioInInterrupted function automatically stops the audio in. The onAudioInReleased function restarts the audio in. This code shows the function that prepares the audio in and the listener and starts a recording. First, at the start of the function, the audio in and listener are created, and the audio in is constructed by adding the listener. Then, the audio in is prepared with the specified input device, the sampling type, the channel type, and the sampling rate. The buffer is created and added to audio in. Finally, the start function of audio in is called to start the recording. This is a function that I've created to stop a recording in the middle of the program. This function stops the audio in and copies the data in the buffer to the file. Finally, to delete the object, the unprepare function of audio in is called, and the objects are deleted. As mentioned previously, an important advantage of audio in is that it supports multi-buffer. As you know, multi-buffer means using more than one buffer. Let's see how the audio in class works when two buffers are added to the class. If you start recording after adding two buffers, of course, the first buffer is used. Then, if the first buffer becomes full, the onAudioInBufferIsFilled function is called. At this time, the first buffer will come as the first parameter. At the same time, the audio in starts recording using the second buffer. If the second buffer is full, the first buffer is used. Even if one buffer becomes full, the application can continue a recording instead of stopping. Therefore, the latency that is caused when the application performs something to handle the full buffer and then resumes the recording can be reduced. The Audio Out class supports low-level audio playback. The playable data is uncompressed PCM data. Like the Audio In class, this class supports mono and stereo channels. This class also supports a sample depth of 8-bit and 16-bit and provides multi-buffer support. The Audio Out class is very similar to the Audio In class, except that the data of the buffer is not recorded but played. This class provides the set volume function so that the user can control the volume during playback. In more detail, the Audio Out class provides the prepare and unprepare functions, such as audio in, but you have to add a buffer by calling the write buffer function and not the add buffer. The Audio Out class also provides get and set volume functions, which are not supported by Audio In. The Audio Out class provides start and stop functions like the Audio In class. Here, the reset function is used to disconnect from the connected buffers and to return to the prepare state. Additionally, the functions to get the minimum and maximum values of the buffer size and to get the settings optimized to the device are the same as those of the Audio In class. As before, the iAudio Out event listener used by the Audio Out class provides functions very similar to those provided by the iAudio In event listener. Let's briefly look at how to play PCM data using the Audio Out class. First, the following procedures to get the data to be played into the buffer are necessary. The Audio Out class is created and constructed. Then, the Audio Out class is prepared using the sample format of the PCM data in the buffer. The buffer is added by calling the write buffer function. If necessary, you can set the volume. Then the audio can be played by calling the start function. Like audio in, audio out is automatically stopped when the device is controlled by another task. If the device is released, the playback is resumed by calling the start function again. If audio out is no longer necessary, you have to unprepare and delete the audio out class. Now, I'm going to wrap up this lecture on the media namespace. The media namespace includes various classes to allow you to easily use media files, such as audio, video, and image files. The image class enables you to encode and decode image files. In addition, the player class is used to support playing back media content. The audio video recorder enables you to create audio or video recording files. The audio in and out classes support low-level recording and low-level playing. In general, these classes are used for sound processing or developing music applications. And finally, the camera class supports real-time previewing and capturing.